In the meter, it have so many resistors. It has so many wires containing resistance. And if Ohm's law states that the temperature can affect the resistance in terms of the flowing of electric charge, it means we should watch our meter very well, and if necessary, we put them in shade where there is the sun. I think we will do that research and see if we have a resistance. Because of a human being resistance that they used to, when you go to hospital, they used to test diabetics, because the diabetics, due to the resistance in the blood is a conductor. That's help the test slip. When the blood fall on the test slip, then it conducts and give you the value. So even the test slips, it's just like the ohmmeter that we use. But I guess that they have been calibrated. They have been. These are the numbers, and it have a meaning against colors. You see, in a resistor color codes, 0. Yeda obade ase sa na da osoro ene asase so ase. Som obade na abode ensmo. Bibia ewo edusua mu agibo technology enie. Today we are coming to learn about resistor color codes. Please look on the board. Resistor color codes. Resistor color codes. When we talk of resistor in electronics, it is a component which have a resistance to reduces or to opposes a flow of electric current. Okay, before you can build any electronic circuit, you must understand the individual function of the component. Like you want to prepare a food. We have food ingredients that you must understand individual function. So to prepare your food. The same apply to electronics. Electronics, like you want to design a television, you want to design a computer, you want to design a mobile phone, you want to design a sound system. You must understand the components that it uses to produce such things. And you must understand the individual function. Today, as we are talking of resistor color codes, resistor too is another electronic component that is designed to reduce the flow of electric current. Today, we are much considering resistor color codes. Any conductor have a resistance, but we have designed a special component called resistor. Before you can know the value or the resistance in the fixed resistor, unless you understand the color codes, because most of the resistors, before you can know the resistance in them, unless you use the colors coded on it, before you can know the resistance in them to resist the flow of electric current. Some of the resistors, the resistance is written on them. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, then gold, silver, 9. These are the numbers, and it have a meaning against colors. You see, in a resistor color codes, 0 is black. 0 is black. The color, when you see 0, is the color black. 1 is brown. 1 is brown. 2 is red. 3 is orange. 4 is yellow. 5 is green. 6 is blue. 7 is violet. 8 is gray. 9 is white. And gold is 5%. Silver is 10%. None is 20%. From this, when you find out a resistor, this is a resistor. And the color is coated on it. Yes, we are using a 4-band resistor. This is first band, second band, third band, and then the fourth band. The fourth band represents the tolerance we use to calculate the tolerance. That is the gold, silver, and none. The first, second, third band that determine the value of the resistance in the resistor. So this resistor, before you can know the value in this resistor, maybe the first band, when you calculate the band, you look at the band which is close to the end. You see, this band is close to the end, so you start from here. You will not start from counting from this place. Always look at the band close to the end and start your first band. Then you skip to the next band and then to the third band. So maybe if this one band is color brown, and this one is red, and the third one is orange, and the fourth one is silver. You must come to the chart here and know what brown stands for. Brown stands for 1 here. Brown stands for 1. As 0 stands for black, stands for red, stands for orange, yellow, you see. So black stands for 1, red stands for 2, orange stands for 3. So here it is 1, 2, 0, 0, 0, or 1, 2 times 10 to 10 to the power 3. You see, so this one, when you expand it, it will be like this, and it will be the same like this. So you will have 1200, which is 12,000 ohms. The SI unit of a resistor is ohms, so you bring 12,000 ohms. But in every 3 zeros, which is positive, you cancel it and write 12 kilo ohms. That is that. So in this resistor, when you see it anywhere, you know that it is brown, red, orange. You get it? But let's go details of this. The first band and second band is multiplied by the third band to get the resistor value, or the resistance in the resistor. So if a resistor having a color of, let's say, this is red, blue, red, you see, and this one is silver. You see, a resistor coated on this color, red, blue, and red. To know the resistance, unless you know what red stand for, what blue stand for. So you come to the chart here. The red is 2, so red is 2 here. Blue is what? Blue is 6, so you come, blue is 6. Another red is 2, so it's times 10 to the power 2. And 10 to the power 2 is 2600. Then you bring the SI unit, ohms. So this, you can convert it to K, and it will be 2.6 kilo ohms resistor. So this resistance in this resistor, when you see 2.6 kilo ohms, you know that it is red, blue, red. That will give you this resistance. So you go to any electronic shop and you tell them, I want 2.6 kilo ohms. They will give you a resistor colored red, blue, and red. Okay. When you go and you are not finding the same 2.6 kilo ohms, then you add the tolerance. So this one is tolerance. Tolerance. The tolerance here, it used to find the equivalent to replace this resistor. So the 4-band, as we are dealing with 4-band resistor, we are dealing with 4-band resistor. We have resistors which are 5-band, 6-band. Okay, but here we are dealing with 4-band resistor. So to find the tolerance of 2.6 kilo ohms, unless you calculate for the tolerance, and the tolerance here is silver, and the silver is 10%. So here you multiply 2600 times, no, it's plus or minus 10/100. You see. So in this calculation, after your calculation, you either deduct the answer minus this or plus this. So what you get, you buy that resistor, you place to, if you are building a circuit or a machine, you put it on, it will be work for you. That is that. So you see, and another way, that is the simplest way. Also, when you find a resistor coated these colors, always the 3rd band is counted in zeros. You find a resistor coated on it and you want to know the resistance. The 1st band, you write it maybe like this. The 1st band, which is 2, you look at the chart, red is 2. The blue is 6. You look at the chart, blue is 6. The 3rd, 1, 2, 3rd is red. You look at the chart, red is 2. But the 3rd band, as we are multiplying by 10 to the power, to the 3rd band, you can just write that the 3rd band, if it is 2, make it 0, 0. If it is 3, make it 0, 0, 0. So the 3rd band number, we count them in zeros. If it is black, we count them in zeros. So here is red, so 0, 0. And it's the same as 10 to the power 2. You see? Then you bring your SI units. Okay, let's see. Let's see. It's green, white, orange. This is a resistor coated on it with the same silver nano. You see? So here, to know the resistance in this resistor, which reduces the flow of electric current, you must understand the colors before. So here, green is what? 5. White is what? 9. Orange is what? 3. So you not write 3 like this. No. Convert it into zeros. 0, 0. Right? 0. You convert into 3 zeros. Or you multiply by 10 to the power 3. And when you expand it, you have 59000 ohms. And you can write it like this to make it convenient. So that if you are writing in the box, it will get inside the box. Like this, it cannot get inside the box. You see, it cannot get inside the box well. But to write it convenient, 5 kilo ohms. Sorry. It's 9 kilo ohms. So any answer, we make a convenient answer. That's all. That is why we convert it in K. And this one is positive. You see, if it is negative, it will be milli. But here is K. You see? Good. So, to know the resistance in the resistor, you must to understand the colors coated on it. And each color is it stands for. So, the color black, it stands for 0. Color brown, it stands for 1, as you seen over here. So, let's consider a resistor which is having yellow, violet, blue. A resistor coated on it yellow, violet, blue. This is the violet, as you can see. VI0. Okay, violet. Good. So here you come to the charts. Yellow is what? 4. Violet is 7. Blue is 6, but it is a third band. You write the first band 4, second band 7, but the third band, you count them in zeros, or you multiply by 10 to the power the third number. You see? So 4 7 times 10 to the power 6, and it is the same as turning the 6 here into zeros, because it's a third band. All third band, change it to zeros and write zeros against the number of zeros against the number. So if it is 5, you write 005. If it is 6, you write 006. But here it is 6, so you write 000 000. Then you bring the SI unit, ohms. You see? But you make the answer convenient. So in a resistor, when all 00030 is make, so you write 47 mega ohms. 47 mega ohms. So when you find this 47 mega ohm anywhere, you know that it is yellow, violet, blue. Please, you get a point. And maybe you have, let's say, 10000K, then the SI unit. We are dealing with the resistor, so any figure must against the ohms. That is the SI unit for resistor. So here, this is the same as 10 kilo ohms. So when you find this and you want to know the colors, you come to the chart. 1 is brown, and it is this. So brown. 0 is black, so it is black. Which number will give us K? And K is 3 zeros. So which number here will give us 3? You look at the chart, orange is 3. So the orange is the third band, because even you look at the number, this is the first band, second band, this is the third band, and the third band we convert it to zeros. So it is 3. So the 3, we don't write 3 as a third band, we don't write it like this, you write it 000. So it is what? Orange. As you look at here, the 3 is orange, and it's the same as K. So orange. You see? So if we give you the colors, you must know the value. Or if we give you the value or the figure like this, you must know the colors. That is that. Let's consider these two. 10 ohms. 10 ohms. If you have a resistor of 10 ohms like this, and you want to know the colors, simply come and look at the chart here. 1 is brown, 0 is black. So we have just ended 2, but it's supposed to be 3. So what is the third band? Okay, you remember, as I said, 0, when you say 0 as a third band, we don't write it, we cancel it. So if it is 5 6 0 and it is green, blue, black, it will be 5, 6 ohms. You cancel this. Or it will be 5, 6 times 10 to the power 0. And 10 to the power 0 is the same as this. So here, it will be black again. It will be black again. The black become third band, we cancel it. We don't write. So if you are to find this, and you know that the brown is 1, black is 0, another black is 0. This is the first band, second band, third band, and the third band, we cancel it. So it will be 10 ohms. You get it? Every third band of a resistor, if you are dealing with the 4 band, every third band of the resistor, if it is 0, we don't write. We cancel it. Or you just multiply by 10 to the power 0. And when you expand it, you will have 10. Please, do you understand? So, resistor color codes, as I said, to know the resistance in a resistor which have a color coded on it, unless you understand this chart. So you chill this chart baba in the head, so that if you come across any resistor coded, or you find any number with the ohms or any resistor value, you know that this is the color, this is what it means. Like, let's say we have 1 mega ohms resistor. 1 mega ohms resistor, it's what? If you want to know the 1 mega ohms resistor, you look at the chart and know, because we are dealing with the 4 band, so this means this is a 4 band resistor. The first, second, and third band, that gives us the value of the resistor. So this one, you see, brown is 1, so it's brown. And this meg, it means that it's 00006. Like K is 0003. Meg 0006. 00006. So here we are to find 1 meg. So you look at the chart and know, okay, it will be brown, which is 1, then it's black, which is the second band in this, then green, that is the third band. So brown is 1, black is 0, green is 5, but you don't write 5 like this. You either multiply by 10 to the power negative 10 to the power 5, or you convert it to 005, 000, 00, 1, 2, 3, 4, 5, 6. Then it is 1 meg. You bring the SI unit, which is ohms. You see, that is that. So the resistors having a color coded on it, to know, you must understand this chart, so to find the value of the resistor. The 4th band we use to calculate for the tolerance. If this is 1 meg and you are not getting the 1 meg, if this one is having 5%, which is good, then you plus or minus 5%. So your answer is either add to the 1 meg or deduct from 1 meg, period. So the answer you get, you buy that resistor and put it there. It will work for you. So the tolerance used to calculate for a covariant to replace. Okay, so that is that for the resistor color codes. That is that for resistor color codes. And I say, to build any circuit, to repair any machine, you must understand all types of resistors and its coding. Some of the resistors, the value is written on it. Some of the resistors uses colors before you can know the value. So resistors which uses the colors, you must understand these charts and keep it baba in the head, so that you can know and identify the value of the resistor. We have instrument that we use to measure the resistance in the resistor, and it is called ohmmeter. Ohmmeter is used to measure resistance in any conductor or anything that have a resistor, which any material which electric current passes through it, it is having a resistance. But here, the resistor, maybe if it is a coated resistor, that resistor is a coated resistor, but the colors is being rubbed. You cannot find the colors. That you may use your ohmmeter to read across. When you use your ohmmeter to read across, you use your ohmmeter to read across, you know the value of a resistor which colors has been rubbed. That is that. And you all know resistor is electronics component that reduces the flow of electric current. That is a resistor. And every conductor have a resistance. Every semiconductor have a resistance. Semiconductor like diode, it have a resistance. But just that, it allows current to flow in one direction, but it has a resistance in them. So when you pass through a 10 volts 5 amps or 10 volts 2 amps to it, the end you not get the same voltage and the same amps. As the Ohm's law state that current passing through a metal must be directly to a voltage if there is no change in either physically the thickness or the temperature or the length of the cable. It must be same, current must be same to voltage. But because the length of the wire or the size of the wire or the conductor or the metal, it does not obey the rule. That's why we measure and know the resistance in any conductor, any material that can flow through it. Even human being, we have a resistance. Because of a human being resistance that they used to, when you go to hospital, they used to test diabetics, because the diabetics, due to the resistance in the blood is a conductor. That's help the test slip. When the blood fall on the test slip, then it conducts and give you the value. So even the test slips, it's just like the ohmmeter that we use. But just that they have been calibrated, they have been designed. But even you can use ohmmeter, digital ohmmeter, to calibrate to the test slip to to do something. I mean that human being is a conductor, and human being, we have a resistance that reduces the flow of electric current. So because of the resistance, the blood is a conductor, and the test slip is reading the resistance. You see, it reads the resistance due to how much sugar or salty in the blood. If there's more sugar in the blood, it will read higher resistance, and if it is you have more salt, it will read lower resistance. But we are not into that details. We are into resistor color codes. The resistor is being designed at the laboratory, but anything that electric current passes through, you see, it is it have a resistance, and you see, the more the higher the resistance, the more electric current found difficult to flow. Let's say we have 10 ohms resistor. If 20 volts power is flowing through 10 ohms resistor, and the same 20 volts is flowing through 100 ohms resistor, the 20 volts will find difficult to flow 100 ohms resistor, but it will find easier to flow 10 ohms resistor. The more the higher of the value or the higher of the resistance that it found difficult to flow through it. Please do get it. The higher the resistance, the voltage found difficult to flow, or the more it will reduce the flowing. The lower resistance, it find easier to flow. That is that. So you must know the resistor color code. So anytime you find out resistors which is quoted on it, you know this resistor have this resistance in it. This resistor have this resistance to reduce the flow of electric current. Resistor is reduces electric flow. It reduces the flow of electric current. It does not allow the actual voltage and current to pass through. As Ohm's law say, current passing through a conductor must be directly proportional to a voltage. But if there is no change in either physical or the length or the size of the wire, the physical, you see, the size of the wire, the thickness, the length, or the temperature, you see, some metals or some conductors, even if the temperature goes high, it increases its resistance. Some it decreases its resistance. So here, I can advise ourselves that our meter, it is better to keep them in a shade, because if a sun strikes highly on our meter, the electrical meter, the one which reads our bill. When the sun hits on our meters very hard, it can affect the reading. Either it will increase the reading or it will decrease the reading. This is my assumption, because in the meter it have so many resistors. It has so many wires containing resistance. And if Ohm's law states that the temperature can affect the resistance in terms of the flowing of electric charge, it means we should watch our meter very well, and if necessary, we put them in shade where there is the sun. I think we will do that research and see. Okay, this is all about resistor color codes, and to identify a resistor coated on it, you must understand this chart. So, thank you for watching. This is Hajbo Technology. Everything is in education. If anything draw my attention, Hajbo Technology, everything is